In this video, we'll have a first look at integration by parts. Integration by parts is a powerful tool for integration, which allows us to integrate a product of two functions. Now, this is something that we previously haven't been able to do unless it was a very specific type of integrand. So, for example, if we had the derivative of a function as one of the two things that's being multiplied. Now, the integration by parts formula, or the rule, is really equivalent to the product rule for differentiation. So with differentiation, if we had two functions of x, u and v, then we could easily differentiate u times v. It's just this formula that's on the screen right now. To get the formula for integration by parts, we're actually going to start off with this product rule for differentiation, and we're going to work towards our integration by parts formula. And the first thing that we're going to do is we're going to integrate both sides of this formula. So let's go ahead and do that. The integral of d on dx of u times v dx is going to be equal to the integral of u dash v plus u v dash dx. Now I'm going to reinforce here, or really focus on the point that u and v are functions of x. So even though I'm writing them as just u and v, they are absolutely functions of x. Otherwise, it wouldn't make sense to take an integral with respect to x. Okay, now the left-hand side. We're integrating a derivative. So that's just going to give us back our original thing, which is uv. So we have u times v here. And on the right-hand side, well, we have the integral of a sum of things. And since integration is a linear operation, we can split that up into two separate integrals. So that's going to be the integral of u dash v dx plus the integral of u v dash dx. Now what I'd like to do is I would like to take this integral, let's change color. I'd like to take this integral to the other side. So that's going to give me uv minus the integral of u dash v dx is equal to the integral of u v dash dx. Now this is actually my formula for integration by parts. Okay, I'm going to rewrite it just a little bit differently. Firstly, I'm going to write the right-hand side on the left-hand side. So I'm going to write the integral of u v dash dx. That's equal to uv minus the integral of u dash v dx. So what have I done? Well, what's on the left-hand side? At the moment, we have a product of functions. This is a product of functions that's being integrated. And what's it actually giving me? Well, it's giving me another integral. Here we have another integral, which is also a product of functions. So this is an integral, you could say integral of a product. So how is that even helpful? I've started with an integral of products, and I'm getting an integral of products. Seems like we're not really getting anywhere. Well, the point is that this second integral, the one that we end up with, the one on the right-hand side, that's actually meant to be simpler than the original one. So what we're doing is, yes, we're getting back another integral. However, that integral is going to be much easier for us to calculate. Well, that's the idea. Sometimes it takes a bit of work to make that simpler, but the idea is that it becomes simpler and we're able to integrate. So that's all we're going to do in this video. In the next few videos, we'll have a look at a few examples.